Okay, let's say you have something like y equals 4 times the sine of x plus 3 versus something like y equals the negation of cosine of, -3 times the cosine of x plus pi over 4. So do you guys see in the first one how there's no parentheses, there's no additional pi's? It looks less scary. But in scenarios like this where there's no parentheses, there's no pi's, there's nothing like that, this is when all you're going to do for this one is like what we were doing the first day, where you just think of the key y coordinates for sine and then multiply by 4 and then add 3. That's all you're doing for these types of problems. It gets a little bit more complicated when we have the parentheses and you have the pi's, because that's when we start shifting and stuff. But when there's no parentheses and it's just straightforward with just numbers, you're just going to do what we were doing that first day. So we remember that sine looks something like that, right? So our key y coordinates for sine will be 0, 1, 0, -1, 0. I hope at this point we have it all memorized. We have the sine and cosine key points for y coordinates for y memorized. Then what we're going to do first is we're going to multiply these key coordinates by 4. So we're 0, 4, 0, -4, 0. Then we will add 3. So 0 plus 3 is 3, 4 plus 3 is 7, 0 plus 3 is 3, -4 plus 3 is 1, 0 plus 3 is 3. And these, -1, thank you. And these are the y coordinates. So I will still ask a series of questions that I was asking last class, which is our amplitude, and we could figure out the amplitude because that's going to sort of be like how high we're going up, right, from the point. So we could figure that out after, or actually, let's just y equals a times the sine of b of x plus c. So isn't our amplitude always the number in front here? So what is our amplitude? 4. It's actually easier. All right, we're also going to find out our period. So the period where it takes for one copy to happen, if you remember, is going to be 2 pi divided by the absolute value of b. So b is the number right after the sine, and that's just 1. So this is just going to be 2 pi. Then we're going to have our quarter period. And for the quarter period, all you're going to do is take your period and divide it by 4. So this becomes pi over 2. And then our horizontal shift. Our horizontal shift is always in parentheses grouped with the x. Right now, this is not in parentheses grouped with the x, and your horizontal shift will always contain a pi in it if there's going to be a horizontal shift. There's no pi, there's nothing grouped with that x, so we are going to say none. Or no horizontal shift, whatever you want to write. And now we sketch this. I think I'm going all the way up to 7. I need to go. Yes.
Is quarter period always pi over 2?
The quarter period, you mean, oh, reducing down to pi over 2? Will it change? I mean, it could change. The quarter period could change because it's all based on the period. So if the period's different, then the quarter period's going to be different. So you'll see ones like that.
But is it always over 4 in the beginning?
It's always whatever the period is over 4 in the beginning, yes. But then we're going to simplify it down to different things. So now remember, we're going to label our x-axis based on our quarter periods. So where the x and y axis crosses 0, 0, the origin, then we said we're going to do pi over 2. So this is going to be pi over 2. This is 2 pi over 2, 3 pi over 2, 4 pi over 2. How many do I want? 5. And then our y-coordinates go from 3 all the way to 7. So we're 1, 2, 3, 4, 5, 6, 7, going positive, and negative, we just go down to -1. So now we plot. So our first point will be 0, 3. Our next one will be pi over 2, 7. The one after that will be 2 pi over 2, 3. Then we'll have 3 pi over 2, -1. And then 4 pi over 2, 3 again. And because we know the shape it's supposed to make, we know that it looks like that, and that's correct.
So pretty much if you just check your work looking at the shape, you should get it right if it's like, the shape that's like accurate. Most likely
Yeah, you might have shifted wrong,
yeah,
but otherwise it should be good. Okay, I want you guys to try, not this one I wrote down, that was just to show you the difference between how they look. I want you guys to try this next one. So this was number 1 from review, this is number 2 from the review. So you're answering all the same questions we answered. It's all there.
So vertical shift is like the x minus whatever, like the minus whatever, like on the outside of parentheses.
Say it one more time.
Like,
the horizontal shift, you mean?
vertical. How do you know when it's a vertical shift?
We don't know a vertical shift. So the vertical shift, oh, you mean, yes, when it's not in the parentheses, yep, that number tells us we're going to shift up or shift down. Yep, exactly. Not in the parentheses is what you mean, right?
Yeah.
Yep.
Not just simple up or down, right? Like negatives down, positives goes up.
Yep. Okay. Very good. Yes.
When you write like pi over 2, pi, 3 pi over 2, and then 2 pi, is that actually just like pi over 2 and then 2 pi over 2 and then 3 pi over 2 and then...
Say it one more time, like which point are we looking at? Right here?
Yeah.
Pi over 2.
On the study guide, like, you write it like, you write the second one as pi and then the fourth one is 2 pi. Are you just like simplifying?
Yeah, so...
Oh, okay.
Because I like to keep it all in the same denominator since our quarter periods are pi over 2.
Yeah.
I just keep adding one more pi over 2 and then another pi over 2. But yeah, those are simplified. Those can be simplified.
Yeah, I read it like that. So that confuses me.
So it has to be exact. Yeah, what's this way? This measures here the y coordinates of y. You gotta go on negative 3 first. So this is negative 3. So just put it on this way. Because it's the first one. Look at the second one. It's negative 4. So maybe the next coordinate is 2.
Guys, can we go over this? Or you want another minute? Another minute? Okay.
You don't care if we like don't write it the exact same way, like the tracing of it, like as like the little V instead of like a...
You want it to be a curve. You don't want it to be a sharp V because that represents something different.
So
And
I should make sure it's like a...
yeah, a curve. Yeah. All right, let's go through this. So back to this one. For this, because there's no parentheses, you don't see any pi within the parentheses with x. This is just a straightforward. And we know cosine looks something like that. So I'm going to take my cosine of x, and I'm going to remember that my key y coordinates for y are going to be 1, 0, -1, 0, 1. But then I'm going to take that, and I'm going to multiply that by -2. So then we are at -2, 0, +2, 0, -2. But then I'm going to take those coordinates and I'm going to subtract 1. So when we subtract 1, we get -3, -1, 1, -1, -3. And these are the y coordinates we're going to use. All right, so now let's answer our questions. Remember, the format for all of these is going to be y equals a cosine of b, open up your parentheses, x minus c. And our first thing we want to answer is our amplitude. Our amplitude is going to be the number in front of the sine or cosine, but we don't use the negative. So what is our amplitude here? Not -2, but +2. And now we want our period. Our period is going to be 2 pi divided by the number after the cosine, but that's just 1. So here it's just going to be 2 pi. It will not always be 2 pi. You'll see ones where it's not 2 pi. So then our quarter period is when we take the period, which is 2 pi, and divide it by 4. So this is just going to be pi over 2. Is there any horizontal shift? No. Now we sketch. So we're not shifting at all, so we're starting at the origin, and then we're going intervals of pi over 2. So I'm pi over 2, 2 pi over 2, 3 pi over 2. I feel like I want, all right. There we go. 4 pi over 2, and I need 5. 1, 2, 3, 4, 5. I need to cover 5 quarter periods. So now our corresponding y coordinates, we're going to go 0, and then was it -3?
Yeah.
And then pi over 2, -1. Yes?
When does it start at 0? When does it start at 1? No, I mean like
The y, where is y 0 and where is y 1 for the beginning? It all is determined, where is it? Here it is, by these numbers. So whatever this first number is, that's your first y coordinate, up or down. So this one was, oh, was I in the wrong one?
No, wait, no.
Oh, sorry, right here, this first one, -3. See how we first took 1, 0, -1. Are you saying with the cosine x and sine x, when does it start at 0? Oh, okay. Sine x starts at 0, cosine x sines at 1, because they're parent graphs. If you remember, the parent graph for the sine of x look like this, and the parent graph for the cosine of x look like that. So the parent graph started at 1 for the cosine of x, and the sine of x started at 0. That's why for sine of x, we always start at 0, and cosine of x, we always start at 1, and then we multiply, add, and subtract accordingly. Did I answer your question now? Matt?
On your answer sheet, you have like the x coordinates, like x, pi over 2, pi, 3 pi, 2, 2 pi.
That's just because I simplified. So look, isn't 2 pi over 2 the same as pi? And 4 pi over 2 the same as 2 pi? I just simplified it a little more, but you don't have to. You don't have to simplify it more. You can leave it just like how I'm leaving it in class. Okay, so we were at 0, -3. Then we were at pi over 2, -1. Then we are at 2 pi +1. And then 3 pi over 2, -1. And 4 pi over 2, -3. So it looks something like that. And you want on either end, where you start and where you end, you want to extend that loop. You want to extend that loop to show these are going to keep going on either side of this. This little copy of this graph, the movement is going to continue. It's going to keep going like this. Do you guys want to try one more of these, or do we want to try one where it's a little bit more complicated, where I have the parentheses and the pi and all that? Complicated? Okay. This is number 4 from your review sheet. Okay, so this is where some shifting begins. Once we get to that point where some shifting begins, inside the parentheses, in front of x, we always want it to be 1. Inside the parentheses, in front of x, we always want it to be 1. If it's not 1, then we pull out a GCF of whatever that number is. We divide it out. So we always want inside the parentheses the number in front of x to be 1. So let's go ahead and answer our questions here. Start off with our amplitude. Well, our amplitude is always the number in front of the cosine, but we don't take the sine. So what is our amplitude? 3. Then we will go on to the period. So now our period is always going to be, remember, 2 pi divided by the absolute value of b. Well, b is the number before the parentheses here. What's that number before the parentheses? Just 1 if nothing's there. So this is going to be just 2 pi divided by 1, which is just 2 pi. Let's go for our quarter period. Our quarter period, all we're going to do is take our period and divide by 4, which will end up being pi over 2. It will not always be pi over 2. The next one I do will be different. Janine, you came. You love us.
Terrible morning.
It was. All right, horizontal shift. Will there be a horizontal shift?
Yeah.
Yes, your horizontal shift is whatever pi expression is inside your parentheses with the x. But remember, it's always the opposite. So because that says plus pi over 4, we're going to shift not to the right, but to the left. So I'm going to say my horizontal shift is pi over 4, and then in parentheses I'll say left. But who remembers from yesterday, our quarter period and our horizontal shift must have the same what? Denominator. So I'm going to make them both have a denominator of 4. So this will become 2 pi over 4. This represents our quarter period, 2 pi over 4. So every 2 pi over 4, that's where we make another movement in our graph. You'll see what I mean when we graph it. All right, let's get to sketching. Let's get to sketching this. Oh, sorry, we didn't do our y's. So we have cosine x. Tice, cosine x, are we starting at 0 or 1? Sine starts at 0. 1. So cosine x, we start at 1. So we're 1, 0, negative 1, 0, 1. And now what are we going to do with that cosine of x, those y coordinates? What are we going to do with it? Multiply it by negative 3. So now we're going to multiply this by negative 3. So this will be negative 3, 0, positive 3, 0, negative 3. Are we good with everything so far? Okay, now we sketch. Tice, you got that down? All right. Ooh, I went a little bit too far. Okay, but now we're shifting. So now we're shifting pi over 4 units to the left. So here's my 0. Here will be negative pi over 4. That is our starting spot. But remember, our quarter period is 2 pi over 4. What does that mean? That means basically every 2 pi over 4 becomes another important point for us. So I have negative pi over 4, then I have 0, then I'll have positive pi over 4. I'm going to just highlight this because that counts as, I guess, our second quarter period, because negative pi over 4 would be our first quarter period. So we have negative pi over 4, that counts as 1. Then pi over 4 counts as the second one. How many do we need altogether? 5. All right, so then I'm going to go to 2 pi over 4. Does that count? No. Then we're 3 pi over 4. Does that count? Yes. Every 2 pi over 4, that counts as our quarter period. So now we still only have 3. Keep going. Does 4 pi over 4 count for us? No. What about 5 pi over 4? Does that count? Yes. So 1, 2, 3, 4. We need 1 more. So does 6 pi over 4 count? No. Does 7 pi over 4 count? Yes. So there is my 5th quarter period. Yes, Nico.
It doesn't count.
So remember how I said we always need 5?
Yeah.
We need to represent 5 quarter periods. So sometimes we just write 5 numbers, right? 5 expressions on the bottom. But because 1 quarter period counts every 2 times because it's 2 pi over 4, so it's every other one counts as a quarter period. So this was our first quarter period just because that's where we started. So now every 2. So here's 1, here's our second one. So now this counts as another key quarter period.
And that's when it's 2. That's when it's 2 pi.
Yeah, if it was 1 pi, then every 1 would count. If it were 3 pi, then every 3 would count. All right, now what we do is we match up our y coordinates to our corresponding x coordinates. So we had our special numbers that we got. So the first one was negative 3. So it's going to be, let me strip this down, negative pi over 4, negative 3. There's our first point. Then I'm not going to put any coordinate on 0, right? Where do I go to next? Pi over 4. Then it's going to be pi over 4, do we know what it is? Pi over 4, 0. Am I going to put anything on 2 pi over 4? No, we now go to 3 pi over 4. So it's going to be 3 pi over 4, 3. And then 5 pi over 4, 0. And 7 pi over 4, negative 3. And we know the shape of the cosine, so it's going to look, oops, something like this. Matt, your phone.
I finished it already.
Oh, you did it already?
I'm only gonna go on it.
I heard you yelling at Matt about his phone at the beginning of the video.
You're famous, Matt. I made you YouTube famous.
You were waiting on him.
I was waiting for him to finish his game. Do you guys want to try one of these by yourself, or do you want to do another one with me?
I'll try one.
Try one on your own? Okay.
How many questions is it?
I want to say like maybe 7, 8.
But that's a good number. You never
I
said
need
that.
2 leave.
It'll be partial credit.
Extra credit. Wow.
Actually, I want to do one more with you. Let me do one more so you see as
Make it
hard.
a really hard one.
So you see as hard as it will get.
Yeah, do the hardest one possible.
12.
Yeah.
12 is not the hardest one. Let's do
16.
let's do 5. 5 is more difficult than 12. I could still do 12, but let's do 5 first.
We have T minus 10 minutes, so.
It's the last one together. I'd hope that we could get you guys to do one of these by yourself, but yeah, it's going to be the last one together.
Yeah, I hope to. Don't worry.
So we have negative cosine, and then 2x minus 3 pi plus 1. Okay. Couple of things here. We know this is one of the more complicated problems. How do we know? Because of the parentheses and the pi in the parentheses, right? So we need to remember, inside the parentheses, what number needs to be in front of the x? 1. There's a 2 there. We can't leave that there. So what am I going to do? I'm going to pull out a GCF of 2 from the entire set of parentheses. How do you do that? You just divide everything by 2. So we're going to have y is equal to negative cosine, and then I'm going to put a 2 here. Open my parentheses, and then we go back and we divide everything by 2. So then I'm just left with x minus 3 pi over 2. Exactly.
This is going to have a vertical and horizontal shift, right?
Very good, Nico. Good. And then we have, don't worry about it, because it's the plus 1. I didn't formally say that. Nico just put it together. But good, Tice. You got that. Look at you.
Locked in.
Okay, so now what I want to do, let's just answer our questions. Our amplitude is always the number in front of the cosine. So we know that's a negative 1. Do we care about the negative? No. So the amplitude is just 1. Now, Tice, this is what I think you were, or no, Nico, was it you asking about the period? Is it always, no, Tice, it was you. You said, is it always going to be pi over 2 pi or pi over 2, whatever it is? No. So here you'll see that it's different. So our period is going to be 2 pi divided by the absolute value of b. Remember, it is y equals a cosine b parentheses x minus c. So our b is the number that's right before the parentheses. What's our b here? 2. So our period is going to be 2 pi divided by 2, which is just pi. That means we'll make one full graph between 0 and pi. That's what it means. Now we want our quarter period. Our quarter period is going to be our period divided by 4, so it's just pi over 4. And last but not least, we want our horizontal shift. our horizontal shift will be 3 pi over 2. It's our C. But now you tell me, are we shifting left or right?
Is that negative? Negative
Right.
To the right, exactly. 3 pi over 2 to the right. So, Matt, it's always the opposite of what's in the parentheses. Before I do anything else, what do I realize about the quarter period and horizontal shift? They're not the same. So we have to create the same denominator. So we will be 2 pi, oh, sorry, not here. We have to change the horizontal shift, not the quarter period. So the horizontal shift, we multiply top and bottom by 2. So it will be 6 pi over 4 to the right.
How do you know if it's going left or right?
So over here, our horizontal shift in our formula-ish is the C. It's always the opposite of the parentheses. So if it's a minus, then it's to the right. If it's a plus, then it's to the left. So because here it was a minus, it's to the right. If this was a plus sign inside the parentheses, then we'd go left. Okay, let's keep going. Yes, Nico.
So because the quarter period has a pi in the numerator, it's like every single one, not like the other problem where it's like every single 2.
Exactly, because it's just 1 pi in the numerator, it's every single one is a key one. All right, I think we're ready to sketch this. Oh, no, I forgot to do our y coordinates. All right, let's do our y coordinates. What happened? I'm always forgetting. I'm always in such a rush. So we have cosine of x is going, Tice, start at 1 or start at 0? Good. 1, 0, negative 1, 0, 1. And then from there, I'm going to, am I multiplying by anything? Good, so if we're multiplying by negative 1, which would be negative 1, 0, positive 1, 0, negative 1. Am I adding anything?
1.
Yep, we're adding 1, so plus 1, which will bring us to 0, 1, 2, 1, 0. And these are our key y coordinates.
We're adding 1 because of the end, right? The end.
Say what happened?
We're adding 1 because of the end.
Because of the end, yeah, exactly.
Yeah.
Can we go to our graph? Okay. Okay, so we said which way were we shifting? We were shifting right, and our quarter period was pi over 4. Our quarter period was pi over 4. Okay. So we'll say pi over 4. Actually, are you guys okay if I just start with 6 pi over 4? Do you guys recognize that that's where we're starting with, 6 pi over 4?
Yeah.
Or you want me to go all the way to 6 pi over 4 and then we're okay? Anybody not okay with starting at 6 pi over 4? Because of our horizontal shift, that's, Janine, you're not okay? You're not okay? Well, do you see that our horizontal shift is 6 pi over 4? Our horizontal shift tells us where we're starting. So instead of me writing all these numbers just for the sake of writing them, we could just start where we're going to start. Does that make sense? So we're going to start at 6 pi over 4. And then every interval after that will be 1 pi over 4. So 6 pi over 4, then 7 pi over 4, and 8 pi over 4, 9 pi over 4, and 10 pi over 4. 1, 2, 3, 4, 5. Okay.
How come you have to skip them?
What happened?
How come you don't have to skip them like you did the last one?
We can. Okay, so maybe it would have been better. I'll go in order. So if this is 0, I don't want to confuse anybody. If this is 0, then this is pi over 4. This is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. This is where we're starting. That's our start point, right? But then from our start point, we need 5 more. So then we're going to go 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4. 1, 2, 3, 4, 5. Okay, so then stay with me. So then we are at, what is it, 0? And then 1, and 2, and 1, and 0. So it looks like this, like this. Do you see how we shifted? Okay, this is what you're up against tomorrow, guys.